We've been jumping around chapter 4 to deal with all the graphing first, and then later on we're going to go to the different sections of chapter 4 where we use algebra and factoring methods and the quadratic formula to solve quadratics. Right now, we're only going to do certain parts of this, just dealing with the graphs. So let's all take a look at this quadratic, and let's graph it. It is an inequality, but we do it the same way. We're going to find the vertex, and the vertex is, or we're going to use the formula, x equals negative b over 2 times a. The b value is 2, the a value is 1, so you have a 2 right there, a 1 right there. You will have negative 2 over 2, so the x value is negative 1. Once you have the x value, we need the y value. We're going to plug it in, and notice that this is an inequality, but I'm going to write it as an equation because I don't want an area of answers. I want the specific y value for when my x value is negative 1. So I'm going to write it like this: y equals x squared plus 2x minus 3, where my x value is negative 1, and I'm going to do the math. Negative 1 times negative 1 is positive 1. 2 times negative 1, that's negative 2. Bring down the minus 3. And you really will get, as a final answer, negative 4. So the vertex y value is negative 4. So the vertex is negative 1, negative 4. And I hope that makes sense. Let's graph that most important point. Negative 1 on the x, negative 4 on the y. There it is. Through any vertex, the most important point, there's an axis of symmetry. That'll provide a reflection. And to get more coordinates, you could use a table, do some inputs, get out some outputs, or the easier thing to do is to recognize that your a value is 1. And when your a value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. I mean, you could even use it if it weren't 1. You could modify it if you wanted to, if it were like the a value of 2. But anyway, from the vertex, you're going to go 1 over 1 up, and you will be at the negative 3. And you can go back to the vertex, go 2 over 4 up. You'll be at that x-axis, at the x value of 1. And then go back to the vertex and go 3 over 9 up. You will be up there right on the edge. And of course, we're going to map them over to the other side using the axis of symmetry. And voila, we have our parabola. But before graphing it, let's go back and understand that this is not an equation. This is an inequality. So is this going to be a solid parabola or dotted? Dotted. If it had a solid line underneath the inequality, then yes, it would be solid. But it does not, so it's going to be a dotted parabola. So everybody do some dots when graphing this U-shaped curve. And yeah, you're right, an inequality we have to shade. Now, how does the shading work? Whenever you have y by itself, if it's a greater than, y is up and down. Greater than is obviously where? Above or below? Up or down? Above. Up. So the y is greater than implies that we're going to go to any point on this parabola and shade up. So when I shade up with a highlighter, it's going to be up there. Go to the vertex, shade up, it'd be up there. Go to any point, shade up, it's going to be right there. So in other words, the shading is going to be what appears to be the inside of the parabola. But in reality, it's not the inside. It's really above every single point of the parabola. We're going to shade everything on the inside of the parabola. And that's it. We've graphed. And that's an essential skill of this section. Now, like I said, in previous years on this section, 4.8, we're supposed to know how to solve these things or these inequalities with algebra, not necessarily sticking with graphing. But today, we're sticking with graphing. In the future, we'll go back and learn how to solve these with algebra. But take a look at this. Right here, we have an inequality, and they want us to solve. So this inequality, they want us to solve, they want us to find the answers. And if you take a look at that quadratic trinomial, that x squared plus 2x minus 3, it's the same exact one as up here, x squared plus 2x minus 3, right? What's the difference? Right here you have a y, and over here you have a 0, okay? Now, if I gave you any quadratic equation and I told you find the answers, remember, answers are the same thing as solutions. They're the same thing as the x-intercepts, right? Now, how do I find x-intercepts, which are answers? You set y equal to 0. So if I did have this y equal to 0, what would it say? It would say 0 is greater than that. And that's exactly what this says. 0 is greater than that. Does that make sense? So I could solve this knowing this graph. The only difference is that we don't have a y anymore, we have a 0 right there. Which means that graphically, when you don't have any more y's, you could just focus in on the x-axis itself, on the x number line itself. So this is what I'm going to do. I'm going to kind of ignore everything up here, and I'm going to kind of ignore everything down here. And I'm just going to look at that number line. Where is the shade on the x number line? The shade is between -3 and +1. And those are open dots. They're open dots because the parabola was dotted. It was not a solid parabola. If it would have been a solid parabola, I would have put solid dots right here. Okay? And the area that's shaded, those are our answers. Is it shaded on the outside or is it shaded on the inside? Inside. So the shade itself is an area that's together. Okay? So I need to write this as a compound inequality written together. It's really easy. Put the smaller number on the left, the bigger number on the right, the x in the middle, and less than symbols. Ladies and gentlemen, that is your answer. That is your answer to this quadratic inequality down here. Any value between -3 and 1 will work. When you plug it in, it'll be a true statement. Okay? So I know that seems a little confusing, but the bottom line is we're going to be focusing in on the graphs, and when you replace the y value with 0, there are no more y's. You could just look at the x number line and determine where your answers will be according to the shade, because the shade is your answers, right? Sometimes you'll have the shade on the outside. Like let's say this parabola would have had a less than symbol. Then you wouldn't have shaded above, you would have shaded below, less than, below, below. So you'd be shading everything on the outside. So if that were the case, then you'd have two inequalities. X is less than -3 that way, and x is greater than 1 that way, with the word or separating them. But because the areas are together, we write them together as a compound inequality. Well, I already erased it off my screen. What was it? -3 is less than x, less than 1. Yeah, there it is. Okay. So let's take a look at this guy down here. And this is more like what you're going to see on the quiz, on the test this Friday and on the practice test. You see, I tell you to solve this quadratic inequality, and I give you this parabola. And it's the same exact thing. The only difference between the above and this one below is that right here the y is set equal to 0. But right here with the y, I have the whole graph already graphed for me. Of course, it's a dotted parabola because it doesn't have a solid line underneath it. If I wanted to, I could do -b over 2 times a, and I would get the x value of 1. And if I plugged it in, I'd get the y value of -4. It's already done for me. I don't have to do any of that stuff. All I have to do is determine what my answers are according to the shading. And of course, it's shaded below and on the outside because that's a less than. So according to the shading, if I just focus in on my x values, this is at an ugly x value. What x value do you think that is? Give me an estimate. It's almost half. Let's say -0.4, right? -0.5. And it is going this way. So what am I going to say? X is less than, because to the left is less than. So this is one inequality. The other inequality, it's about let's say 2.4, and it's going this way to the right. So that's going to say x is greater than about 2.4. Okay, so both of these are my answers, but because the areas are apart, I need to write both of these with the word or between them. Okay, not together as a compound inequality. So on this particular problem, I need to write x is less than -0.4 or x is greater than 2.4. And it's not exact. I know it's not exact. Right here it says give an approximation. And like I said, in the future we'll be solving these with the quadratic formula. We'll be able to get decimals, like exact decimals. Right here we're just doing it visually, so I hope we understand how to do this, yeah? Yeah, on the test, I'll give you it'll be like right at 1 and right at 2, so you'll get nice x values on the test. As a matter of fact, on the test, I think the majority of them are not even in standard form. The majority of them are in vertex form, and vertex is way easier to look at when you think about the graph. Okay, so if you understand what we're talking about today, you're really going to understand what we're doing on the practice test tomorrow and on the test the day after that.
Vertex is the one we learned a long time ago, right?
Yeah, where you have an H and K, and that's how you identify the vertex. Anyway, take a look at this one. Again, they want us to solve, but they give us this parabola, which is the same exact quadratic equation here. X squared plus 4, there it is, x squared plus 4. It's opening up to the x squared plus 4. It's opening up to the x squared plus 4. Instead of y, there's a 0. So it's kind of like I'm trying to find the x-intercepts. I'm trying to find the x values that work, that are in the shade. Which x values are in the shade? Let me repeat that. Which x values are in the shade? All of them, right? The -4 is in the shade, the -3, the -2, all of them are in the shade. So what does that mean? That means x equals all real numbers, okay? Now, it'd be a different story if this were not an inequality. If it was like an equal sign, yeah, you'd have your parabola. Where are the x-intercepts? Oh, there are no x-intercepts, right? But this is an inequality. On top of the parabola, you got to decide where your answers are at. They're either above, which would be inside, or below, which would be on the outside. Of course, it's below, so you shade in everything on the outside. And when you see the x-axis, what part of the x-axis is in that shade? The whole thing's in the shade, right? So sometimes you'll have the whole thing in the shade. Sometimes you'll just have a certain part of the line from -3 to +1 together in the shade, so you'd have to write it as a compound inequality. Sometimes you'll have the shade going out that way, so x is less than a certain value, or x is greater than a certain value, so it's going out. There's other cases too, like you may have one, like let's say I had a y is greater than x minus 2 squared. Let's say something like that. How do I graph that? Let's make it a greater than or equal to. How do I graph that? Anybody? It's in vertex form, so the vertex is at 2, 0, right? At +2 on the x. So 1, 2, put a dot right there, right? HK, think opposite on H, take K for what it is, which is 0. So the vertex is 2, 0. So does this open up or down? Up. Okay, and of course it has the a value of 1, so you have the pattern 1, 1, 2, 4, 3, 9. Is it going to be a solid parabola or dotted? Solid. So solid parabola. Solid parabola. There's your sketch. Do I shade above or below? I shade above. Okay, so let me ask you this. What part of your x, what part of your x number line is shaded? Only this value right here. Only the x value of 2. So right here, even for this inequality, the only answer that works is x being equal to 2. Make sense? It could also be like if you had something like, what if I would have had, let's say, what if I would have had y is less than or equal to, now we'll say just less than, same thing, x minus 2 squared. Now, you know what? We're going to make it a greater than this time. I'm sorry. Just to give you a different situation, greater than. But let's make it a negative a value. I'm not changing everything on you. Sorry about that. Greater than negative a value. Okay, so what would this look like when I sketch it? There's a vertex at +2 on the x. The vertex would be 2, 0. That's right. Okay, what else? It's going down with the a value of 1. So that's down 1 over 1 down, 2 over 4 down, 3 over 9 down. Opposite direction. Okay, now also dotted. Yeah, this is just a sketch. It's not accurate. I know. Do I shade above or below? Above in this case. Okay. So here's my shading. Above, above, above.
So it switches where you're shading it depending on the sign.
Well, it depends on the parabola, and the shading is you shade above if it's greater than, below if it's less than. But what I want to do is ask you what part of my x numbers, all of it, except for 2. So you would say x equals all real numbers, but x cannot be 2. Pretty weird, right? Because it's dotted. And dotted means that it's not or equal to. And if it's not or equal to, you can't include it. Make sense? Yeah. All right, so I think we got it down. Let's go. Now, like I said, if we look at, oh my gosh, whoops. If we look at this, these practice problems, these are really not designed for graphing. I mean, if I tried to graph this guy, I'd have -3 over 2 times 1. I'd have a fraction 3/2. That's really ugly. So, like I said, this is more intended for you already know how to solve these with algebra or with the quadratic formula. But since we want to focus in on graphing, there's only a few that actually work out at least decent for graphing. Like number 3, that'll kind of work out for graphing. Should we do that one? Okay, so let's find the vertex. X equals -b over 2 times a. You're going to use negative parenthesis over 2 times parenthesis. The b value is 2, the a value is 1, so you have a 2 and a 1. So you have x equaling -2 over 2. That's going to be a -1. So our vertex x value is -1. For our y value, I'm going to plug it back in. Now, I am going to write this quadratic trinomial set equal to y. So I'm going to write y equals x squared plus 2x plus 1. I know you're thinking, well, why are you putting an equal sign? And there's not even a y to start with. Again, we're solving by graphing. So I'm going to put the y on this side. I'm going to put an equal sign just because I want the exact value of my y value on my vertex. So let me plug in -1 right in there. And when I work this out, -1 squared, that's +1. 2 times -1, that's -2. Bring down +1. 1 minus 2 plus 1, that is 0. So we have a 0 right there. Okay? So that's our vertex. Let's actually graph this thing. But before graphing it, let's take this and imagine that this were a y. Because after all, to find the answers is finding the x-intercepts. And to find the x-intercepts, we must set y equal to 0. And that's why we have a 0 here. So let's write it the correct way. Y is less than this stuff. Reading it backwards, it would be y is less than this stuff. So I want to read it the right way now. Y is less than that stuff. Does that make sense? Yeah. Okay, good. And now that we have it in a more appealing way to graph it, we already know the vertex. Let's sketch it. It's at -1, 0. Does it open up or down? According to the a value, positive a value of 1. So yeah, it's going to be opening up with the pattern 1, 1, 2, 4, 3, 9. So 1, 1, 2, 4, 3, 9, right? And you map it over to the other side. This is just a sketch, no big deal. Is this going to be a solid parabola or dotted? Dotted, so put some dots. Do I shade above or below? According to this inequality that says less than. Below. Less than, get the parabola, shade below, shade below, shade below, shade below. So in a sense, it looks like you're shading the outside. They're all shaded but one. So what do we say here? X equals all real numbers, but x cannot equal -1. Perfect. Cool. You have to put the but unless this were or equal to, then that would have been a solid parabola. Then that would include that value, which means x equals all real numbers without anything. Make sense? Yes. Okay. So yeah, like I said, this is not going to be that nice because they're all in standard form, and on the test they'll be nice and easy in vertex form. It'll be really easy to sketch it compared to these guys. If we jump to the other worksheet, there's only certain questions that are doable, where you don't end up with fractions. So if you want, I would copy down numbers 4, 8, 9, 10, 12, and 14. Just make a list. 1 through 3, I mean, yeah, we already know how to graph, so I wouldn't even bother with 1 through 3. You could if you want to. The solutions are posted. But if you're going to try solving using graphs, I would try 4, 8, 9, 10, 12, and 14. Because the other ones, like number 5, the b value is odd. You're going to end up with a fraction when you try to graph it. The vertex will have a fraction in it. We don't like that. Let's not mess with that. So these are the numbers that kind of work out, at least nicer than the other ones. Should we do one of those? Yeah. Pick one. 10? Let's take a look at number 10. Why not? All right, how do we begin this thing? Vertex. And of course, in the future, you're going to be able to solve these with algebra, not by graphing. But the vertex is x equals negative b over 2 times a. B value is 14, a value is 1. So we have 14 divided by 2. So we really have x equals negative 14 divided by 2. That's saying x equals negative 7. Well, that's going to be ugly. Anyway, let's keep going. Again, I am going to, how about this? From the beginning, I would like a y right here. So I'm going to flip this whole thing over. I'm going to put a y on this side. It's going to read y. But notice that if this were a y, it'd be opening up to the quadratic trinomial. So it has to continue to open up to the quadratic trinomial x squared plus 14x plus 49. And there's a line underneath it. Sorry about that. It's a less than or equal to. So now it's nicer. It's more ready to graph it, right? But we still have the x value. We want the y value of our vertex. So I'm going to pretend that it's just saying equals just to find that y value. So it's going to be y equals x squared plus 14x plus 49. We're plugging in negative 7, negative 7. We have, that's a positive 49. What's negative 7 times 14? Negative 98. Okay. And plus 49. So if we get a calculator and go positive 49, take away 98, plus 49, I believe that is 0. So yes, that y value is 0. So the vertex is negative 7 comma 0. Let's go to a xy plane and let's sketch this thing, or at least try to sketch this thing. That's going to be at negative 7 comma 0. That is right here on the x-axis itself. If I look at this nicer one that's ready to graph, is it going to be opening up or down? Up. The a value's 1, which means I have 1, 1, 2, 4, 3, 9. Is it going to be a solid parabola or dotted? Solid, because it has a solid line underneath the inequality. And now, do I shade above or below the parabola? Below, because it's a less than symbol, right? Less than, so you shade below. So if I get my highlighter, go to the vertex, and I shade below, it's obviously going to be on the outside. Any point on the parabola below will be on the outside. So everything is shaded on the outside. And if I wanted to talk specifically about the x values, that's right, x equals all real numbers. Everything is shaded. And even this point that touches, because it's an or equal to, it's including that point. So yeah, every single point on the x-axis is a solution. X equals all real numbers.
When is when we put the button?
Well, if this parabola would have been dotted, then it wouldn't have been an or equal to, which means you could not include the parabola itself, which means that dot right there would not be a solid dot, it'd be an open dot. So it'd be all real numbers, but it would not be able to be negative 6. Make sense? Okay. Sometimes you will get all real numbers, sometimes you get no solution. It all depends. Should we do another, or are you guys ready to practice? One more? Up to you. Yes, you ready to practice, or yes, one more? Okay, let's do 12. Uh-oh. Look, 12's ugly. It's ugly because it's not even set up as a standard form quadratic trinomial. So I recommend let's move things around, make it look nicer. Minus 8x, minus 8x. Rewrite this thing, negative x squared minus 8x minus 15. It's opening up to 0. And, well, it's not that it's opening up to 0, but it's greater than or equal to 0. because we moved the 8x. There's no more 8x, so there's nothing there. So there's a 0 there.
Oh, so you just put it on the other side?
Yeah.
Yeah, and then now, of course, the 0, that's where we want to put our y, okay? But instead of having the y on the left side, on the right side over here, it's better to have the y over here. But just keep in mind, if I did have my y here, it has to open up to the quadratic trinomial. So it has to continue to open up to the quadratic trinomial, the negative x squared minus 8x minus 15. All I did was rearrange it so it looks nicer, and it's now ready to graph. So let's find the vertex. X equals negative b over 2 times a. The b value is negative 8. The a value is negative 1. So you will have x equals positive 8 over negative 2, so x equals negative 4. And that is your vertex x value of negative 4. We are going to plug it in, but we're going to pretend that it says equals. Y equals negative x squared minus 8x minus 15. Why do I pretend it's equals? Because I want a specific y value on my vertex. I don't want an area of my y values. I want a specific y value. That's why I say equals. So let's plug in the negative 4 right in there. We're going to end up with positive 16. But don't forget about that negative sign that's in front. Bring that down. Some students say, oh, a negative and a negative, I changed the positive. That's wrong. You got to do exponents first and then deal with that minus sign. So that's actually a negative 16. Negative 8 times negative 4 is positive 32. Bring down the minus 15. From left to right, negative 16, you owe somebody $16, but you have 32. You could pay them off. You will have 16 left over. Bring down the minus 15. That's going to be a 1. So the vertex y value is 1. So let's graph this thing. And again, we're using this new modified one that looks nicer.
Flip it, it goes down.
So the vertex is at negative 4, 1. Here's my vertex. And the a value is negative 1, which means it's opening down, right? With the pattern 1, 1, 2, 4, 3, 9. So check this out. From the vertex, you have a axis of symmetry running right through the x value of negative 4. But from the vertex, if you move 1 over and 1 down, you're going to be on the x-axis itself right there at that location. And if you map it over to the other side, you're going to be 1 unit away from the axis of symmetry right there as well. And that's already good enough. Your parabola will be solid because it does have a solid line underneath the inequality. So it's going to be solid, opening down at those two x-intercept values. Do I shade above or below? Below. Any point on the parabola shaded below because it's a less than symbol. So in other words, it's shaded on the inside, right? Not the outside. Let me shade it really good on the inside.
Negative 5 is less than 3.
Yeah, so we want to just focus in on the x-axis itself. This is a negative 3, that's a negative 4, that's a negative 5. We are between the solid dot at negative 5 and the solid dot at negative 3 between, right? So those areas are together, which means we need to write it as a compound inequality written together. Negative 5, negative 3, x in the middle, less than symbols. Because it's a solid parabola, you put solid lines underneath the inequality, and there's your answer right there. This is not, it's not fun, but it's not that bad, and it'll be even easier on the test because, like I said, these are standard form. On the test, you'll have vertex form, which are ready just to look at your H and K, and you already know where the vertex is at.
There'll be no standard form on the test?
There might be one standard form on the test, but not. Most of them will be in vertex form, nice and easy to graph. And of course, if you look at your solutions, you'll be able to check your answers. Which one did we just do? 12? Yeah, there it is. Negative 5 is less than or equal to x is less than or equal to negative 3. Number 9, that one's no solution. That I could already tell if it's no solution and it's opening up, it'll be a parabola that's solid, that's opening up, that's shaded above. So none of the shade will be on the x-axis itself. That's why it's a no solution. Anyway, that's about it.